In previous lesson, we created an empty index and also added a mapping on one of the field. Okay, so now in this lesson, let's create a Pig program which can load the data from a Hive table into Pig relations and finally from Pig to Elasticsearch. Okay, so let's bring the terminal, and there is a file called pig to es.pig. This is a Pig script. Let's open it. Okay. Let's walk through the script. So first statement, which is a register statement, is basically linking the jar file which we had downloaded in previous lessons to integrate Elasticsearch with Hadoop systems. Okay, so we need to include that jar into our program. So let's walk through the code. Okay, first statement is a register statement, which is just adding the jar which we had downloaded in our previous lessons, and this jar is basically integrating Hadoop systems with Elasticsearch. Okay, and in the next statement we have a define statement where we are creating a macro. So this is an optional statement. We are only adding it here to have a cleaner program. Okay, so what this statement is doing is creating a new macro, kind of a function in other languages, called ES storage. And basically whenever we specify ES storage in our program later, it will call this function. Okay, and this function is coming from the jar file we have added. So in this function, basically we are connecting Pig to Elasticsearch. This is the only function we need. And we are specifying few parameters. Okay, these are also optional parameters. We can use the default values provided by Elasticsearch, but we are changing some of the values just for the learning purposes. So the first property we are changing, and this is the Elasticsearch property, and it's a timeout property. So if within 5 minutes, if we do not get a response or our program is hung, then this execution will be killed. Okay. Next property is to create the index if it is not existing. The third property we have is for the mapping of the fields. So in Pig, we will load the data from Hive table. When we load the data in Pig, it also has the schema information, okay, the field names and all that. And we want to use the same field names in Elasticsearch while indexing the documents. Okay, so this is what this property is specifying. All right. Next are two other parameters we have, which is to improve the performance of overall program. But in our case, it's a small data set, only 16,000 records. So it will not need these parameters as such. But for larger data sets, you certainly want to have parallel instances of the same script running. All right. Now here our actual program starts. The first statement is to load all the data which is there in the table called vg underscore sales. Okay, and that table is in a Hive database called Udemy. So using this statement, load database dot table using this function, which is as catalog loader. Okay, and it is used to load any Hive table in Pig. Okay, and next is we are specifying its fields and the type of each of the fields. So this table has a field called rank, and it is of a character type, then a name, which is also character type, so on and so forth. Okay, so basically we are loading all the fields, all the columns in table VG sales, and we are putting all those records into a relation called all underscore games. Okay, so relations are kind of data structures in Pig. Okay, so let's move to the next statement. Next, in our program, we don't want to load everything into Elasticsearch. We only want records of games which were launched in year 2012. Okay, that's what we are doing in the next statement. Here we are filtering all the records by year column, and that should have a value 2012. Right, and next statement, we are ordering our records based on the global sales column. Okay, this will not make much of difference. This is just for illustration here. We may not need this thing because in Elasticsearch when you index, there's no such order maintained. Okay, it's a search which is important. All right, so let's move on to the next statement, which is target. All right, so finally, once we have our filter records, a small set of the records for 2012. We want all these records to go to the Elasticsearch. Okay, and we are preparing that final data set in a relation called target. And the way we are doing is, first we want all the columns, whatever fields we pulled from Hive table, we want all of them to be stored. But on top of that, we also want to club some of the fields. As you may have noticed, the sales data in this data set, there are multiple fields for sales data, right? So we want all the sales data to be under one column called sales, okay? And the way it will be stored in Elasticsearch is kind of a structure, and I'll show you how it will look when it is loaded into Elasticsearch. So in order to club all the sales data, all the fields into one field, we use something called a two-tuple. It's a function provided in Pig. Basically, it will combine all these values and store them as one tuple in sales. Okay, and finally it will be shown as a structure in Elasticsearch, and we'll see how this looks. Okay, once we have our final data set ready, we can just send it to Elasticsearch, and it's very easy to do. We use a function called store. This is also Pig function, and we are saying store target. Target is our final data set into index, which is games slash year. This is a type, and we want a dynamic type. Okay, in this case we are only loading data for 2012. What if you are loading data for all the years and you want all of them to be stored into different types under same index? Okay, you can do that by dynamically creating your types, and you can do that by specifying the field whose value you want to use in naming the types. Okay, and here we are using the year field, and it is in the target. And finally we are saying using ES storage. This is our macro we created in the very beginning. So this will finally send target data set to Elasticsearch. Okay, so let's run this and see how it works. Okay, now in order to run Pig script, we need to invoke Pig binary. Okay, and since we are using H catalog to load the data from Hive, we have to use a flag called use H catalog, and then our script name. Okay, when you run this, it will take few seconds and then it will finally load the data into Elasticsearch. So let's do it. As you can see, now a Pig script is running and it's connecting to Elasticsearch. It's preparing all the data set for it. Let me pause it here, and it may take few seconds to complete. Okay, looks like our index has created. So let's bring the head plugin, and once we refresh, we should see games index. Earlier it was empty. Now we can see 657 documents added to it, and we can also look at these documents under browser. So go to your index called games, and here, as you can see, index games and type year 2012. So this is dynamically created. Okay, and we have all the records we inserted. All right, the one I want you to see is the sales data. You remember we clubbed all the sales fields into one structure, and this is how they will look in Elasticsearch. And if we click one of the records, you can see how sales data is clubbed together under a field called sales. Okay, they all under one field, so it's kind of a structure. And all remaining fields, rank, name, platform, they are stored as they were in the Hive table. So we completed a data pipeline, and in this one we loaded a Hive table into Pig, did some manipulation with that data, and finally send it out for indexing in Elasticsearch. So this is one data pipeline. In next lesson, we will create the second data pipeline, which will work in the reverse direction, where we will read something from Elasticsearch to Pig, and from Pig, maybe we can load it back into a Hive table, or we can store it on SDFS Hadoop file system. Okay, so I'll see you in the next class.